3.4, solve equations.
Bro, not.
It's a little bit different with variables on both sides.
What are variables again? X.
Letters.
Oh, okay. We've done this before. Oh, wait. Oh, yeah.
So basically exactly what we've been doing, except for now there's going to be like x's or whatever the variable is on both sides of the equation instead of just on one.
Do we have to write notes for this one, or we go straight into it?
Straight into examples.
I like
There's
how
not
we-
really any notes that go with this section.
I like how we do
The rest of the chapter, different story. This section, this is the last of just basic solving equations. Then it's going to get into more, obviously, we're doing like ratios,
No.
percents, decimals,
Those are actually like worse than division problems.
cross multiplication.
Oh, I like.
Oh, that's actually easy.
We get to be the pretzel. All right, solve the equation. Number 4, k plus 1 is equal to 3k. Just deleted my k. Minus 1. All right, so there's two different ways that we can kind of go about this. I can either do one, like literally just one step at a time, or I can do two things at the same time. For right now, I'm going to show you one step at a time. But if you get to the point where you can do multiple things at the same time and not get confused, I'm going to let you do that. Okay, so I'm going to move all the k's to the left, all the numbers to the right ultimately. But first, I'm going to move the k, so minus 3k on both sides. So I have negative 2k plus 1 equals negative 1. Gonna throw it. Throw it across the room. Okay. Equals negative 1. Now I'm going to subtract 1 from both sides. So I have negative 2k is equal to negative 2. Then I'm going to divide by negative 2. And then I'm going to get k is equal to positive 1. Now, I'm going to show you how I can do this like whole chunk of steps that I just did right here that took all this space in one step. If you need to do it in two, that or one, that's fine, like individual. If you want to do it all together, that's also fine. So I'm going to come over here and rewrite this problem. So I know I'm moving the k's over this way, so I can say, okay, well, subtract 3k from both sides. But I can also say, well, I know that all my numbers are going the other way, so I can go ahead and undo it over here. You just have to remember that it's the stuff stacked on top of each other. So I've got k minus 3k is negative 2k. 1 minus 1 is gone. 3k minus 3k over here, that canceled. And then negative 1 minus 1 is negative 2. And then divide by negative 2, k equals 1. So if you want to save some steps, you can do it that way. If you want to do it all individual, you can also do it that way. You're going to get the same answer either way. When we check these, I'm going to just show you one for how you would check this. We would plug in 1 for k, so 1 plus 1 is equal to 3 times 1 minus 1. 1 plus 1 is 2. 3 times 1 is 3, minus 1 is 2. 2 equals 2, so I know that I did it right. I'm going to take the hairbrush away if you're not going to focus. Okay. So again, I don't care which method you use, as long as you get to the right answer, I don't really care. Number 6. 8 plus 4m equals 9m minus 7. Now, does it matter if my variables are on the right or the left?
No.
Nope. So in this one, just for fun, I'm going to move the variables to the right and the numbers to the left. So I'm going to subtract 4m first. So I get 8 is equal to 5m minus 7. Then I would add 7. So 15 is equal to 5m. Divide by 5. So 3 is equal to m. Or do y'all like just doing like one step at a time, or would you prefer to do both moving at the same time?
One step.
Okay. Those of you that like to do it all at the same time, you're welcome to do that, but I'm going to keep just doing one at a time for right now while we're getting used to it. I just wanted to see what y'all thought. All right, 8. 19 minus 13p equals negative 17p minus 5. All right, so what do we need to do first? And I don't care which way you move stuff. You just got to tell me what to do.
Add 13 plus 7.
So I'm going to add the 13 to both sides. So we're moving it over to the right. I think that's what y'all were trying to say to do. All right, so I have 19 is equal to negative 4p minus 5. Now what?
Add 5 to both sides.
Add 5. So 24 is equal to negative 4p. Then what?
Divide by -4.
Divide by negative 4. So I get negative 6 is equal to p. Um, 12. 7 times r plus 7 equals 5r plus 59. So if I have one like this, I need to distribute first before I do anything else. So I'm going to distribute this 7 to both of these. So 7r plus 49 equals 5r plus 59. Once I do that, it's just like the other stuff. So subtract 5r. I'm left with 2r plus 49 equals 59. Then what? Subtract 49. So 2r is equal to 10. Divide by 2. R equals 5. Um, 14. 5 times n plus 2 is equal to 3/5 times 5 plus 10n. All right, so what's my first step on this problem? Yep, I've got to distribute on both sides. So over here, I've got 5n plus 10. Now, over here, I think I heard somebody say, oh no, and you saw the fraction. This is okay because I have a 5 on the bottom. Both of these numbers are divisible by 5, right? So they're going to go away. So if I do 3/5 times 5, my 5's cancel, and I'm left with 3. Okay? Then over here, when I do it 3/5 times 10n, 5 goes into 10 2 times. 3 times 2n would be 6n. And so that's how that would work. A lot of people think once they cancel like the 5's here that all of a sudden magically the 5 just disappeared. It doesn't disappear. We have to be able to reduce it from both, like out of both things. Okay, so just make sure you watch that. That's why I showed it the way that I did. All right. So now, what do y'all want to do next? Subtract 5n, then this actually works out nice because I got 10 is equal to 3 plus n. Now, when I do my next step, I'm completely done. I don't have a division step. So I wrote minus 7, minus 3. So 7 is equal to n.
Wait, does that mean a cookie in the jar?
No, because I fixed it. All right. Questions on those? You good? All right. So the next problem say to solve the equation if possible. So, so let's hypothetically say, just backtrack for a second, that this had been a 6n over here. When I subtracted 6n from both sides, the n's would go away, and I would have been left with 10 is equal to 3. Well, is that a true statement? No. So that one would have been no solution.
Oh, okay.
Okay? So basically, if we can solve it, we're solving it. If not, it's no solution. They sound complicated, but they're actually not. All right. 18. W plus 3 equals W plus 6. Man, we need Sean. There's a W in this problem. Huh?
I was repeating.
Oh. I thought you were like actually asking me a question, and I was like, I haven't done anything yet, but copy the problem down. All right, so I'm going to subtract W from both sides. Well, when I do that, both W's or all the W's cancel, and I'm left with 3 is equal to 6. Well, that's never a true statement, so there is no solution for this problem. There's no solution that can make this true.
Oh, Stacy, for no solution, could we put a 0 and an exclamation? Huh? Yeah, remember how we did a circle through the Oh.
No, you need to write no solution.
Okay. So, solve.
I mean, you can write it out. This is an abbreviation of solution.
I like abbreviations.
But you can write it out if you really want to write it out. 22. 22x plus 70 equals 17x minus 95. So what do I do on this one? Subtract 17x. So I get 5x plus 70 equals negative 95. Now what?
Minus 7.
Subtract 70. 5x is equal to 165, negative 165. Let me make that look prettier. Hold on. And then divide by 5. X equals
33.
Yep. Negative 33. So on that one, obviously we were able to solve it. That one did have a solution. 24. 12y plus 6 equals 6 times 2y plus 1. So what do I have to do first on this kind of a problem?
Oh my gosh.
Distribute. So 12y plus 6 equals 12y plus 6.
What do we do?
If they are completely equal, they are identical, or when we were to solve it out, like if I were to subtract 12y from both sides, then I would have 6 is equal to 6. That's always true. So this is called an identity. Okay. That's like if I was going to give you any notes from this entire section, it would have literally been the word identity. And basically they say, equations do not always have one solution. An equation that is true for all values of the variable is an identity. So the solution of an identity is all real numbers. Some equations also have no solution, which we've already seen. So any number that I plug in for y, I could plug in 2, I could plug in 500, I could plug in negative 73. No matter what value I plug in, this is always going to be equal. Okay, so that's what an identity means. So if it's something that's always true, or ultimately like I would get down if I subtracted 6 from both sides, I'd have 0 equals 0. That's an identity. when you get to Algebra 2, or well, I think we actually will hit it a little bit at the end of this year. When we're solving two equations with two unknowns, which is much farther in the distance than where we are right now, if you get something like 0 equals 0 that's always true, we call it infinitely many solutions, okay? Because that means that there's an infinite amount of solutions that will solve the problem. But that's all you need to know for right now. I'm gonna assume that y'all probably don't want to do all these problems that have fractions in them.
Yes, please. No.
No.
No, I don't want to do it. I don't want to do it. Thank you.
I was like, I mean, we can, but...
No.
All right, one other thing in this section that we do need to look at, though, is with perimeter. Was that this class we were doing something with perimeter the other day?
Yeah.
Okay.
I did it yesterday.
The homework I did not understand. The like perimeter part.
It was easy.
You had to convert one of the things to be able to do it.
What is that?
All right, 44. They want us to find the perimeter of the square. So they tell us that this side is 6x.
You draw it so perfect again. Oh my God.
Magic. This side is 8x minus 10. So what do I need to know to be able to find the perimeter of the square?
You need to know the.
I need to know x. How do you think I should go about solving for x?
So you should do
2 times length is 2 times width.
That's for a rectangle.
That looks like a rectangle.
4.
I just said that this is a square.
It's 4. Wait, no, it's not.
But there's
I need to solve for x. Now, what do I know about the sides of a square?
they're even.
They're all the same. So, I'm going to set this up as 6x is equal to 8x minus 10. And I'm going to solve for x. Then I'm going to find the perimeter of my square.
Oh, so.
So, minus 8x. So, I have negative 2x is equal to negative 10. Divide by negative 2. X is equal to 5. I am not done.
What?
Times
Not?
by 4.
I have to find the perimeter of the square. I now have to take this and plug it in for x up here to solve for the side. So 6 times 5 is equal to 30.
And that's. Oh,
Now I can multiply that number by 4. 30 times 4
120.
would be equal to the perimeter of the square. Trying to draw my little square. Come on. Okay. So 120 would be the perimeter of the square. Okay, now I chose this one because it was easier. 6 times 5 is easier than 8 times 5 minus 10. But if I did this way, I would get the same thing. 8 times 5 minus 10 is 40 minus 10, which is also 30. So either side would have worked for me, okay? If these were rectangles, I would obviously have to do both of them, but then the method that I used wouldn't work because obviously can't set them equal to each other. Last one, 46.
Oh, that. Whoa.
4x minus 2 and 3x plus 7. I want you to try this one on your own paper.
Wait, hold on. On 44, where did the 4 come from? Because
The perimeter, 4 sides.
oh,
The perimeter of a square is, I don't know why it's sideways, 4 times the side length. Do you have a question? I'm giving everybody a chance to do it. Then I'll ask for everybody to give me their answers. So we can see if we all know what we're doing. Drew, do you have a purple water bottle?
It's not mine, it's Taylor's. She
Oh.
had it here, and I like do this, and I'm hitting the head, so I got a board and I put it in.
Oh.
Always touching my stuff. You're a candle.
All right, do we have an answer?
I do.
Just say it.
136.
What was x equal to?
2, 7.
9.
Oh gosh.
9.
What? I got 7.
4 times 7?
What'd you get?
Did you remember to add the 2 over?
I didn't. Oh,
Where did that? Hold up.
I thought 4 times 9 was 30.
Okay.
No. Wait, what's in my...
Oh,
4 times
I
9
forgot about
is
the
36
minus
minus 2.
All right, so we have, to find it, we set both of them things that they gave us equal to each other and solved. And when you do that, you get x is equal to 9 after all of that. I plugged it into the 4x minus 2. You could have plugged it into 3x plus 7. You would get the same thing either way. So 4 times 9 minus 2 is 36 minus 2, which is 34. Then the perimeter is to take that value and multiply it by 4, and it's 136.
Oh, I found out what I got.
Are you a cowgirl today? Yeah, it's cowgirl night.
Yup.
I forgot where the heck came from.
Are you staying?
I'm staying through, then I'm leaving, then I'm coming back. I had my aunt's birthday dinner, so I'm staying until
Well, you
5.
could have your mom bring you your stuff.
Well, no, because my stuff, I'm gonna mostly work in the varsity game, so I'm just gonna grab my stuff at my grandma's house, because my grandma's house is right by my house. They're right
Yeah, that's what I'm.
across-
Oh, well, that's what I'm saying. Just like grab it later when we leave. All right.
My grandma was
I help Dylan, Dylan with everything. With this practice essay. We used to have 4, but now we have 1 really good.
All right. 3 through 23, every other odd,
Yes, thank you so much.
and also 31 and 45.
Oh my gosh, you're so nice.